Do you people all want to answer, or are you just? Okay, hang on then. Hang on. Give me a second here. Let me finish getting attendance. I love the enthusiasm. Love it, love it, love it. Okay. All right. So who's got something that is not matter? Oh, man. All these hands, all these people got great answers. Go ahead, JVB. Sound actually is matter.
Is it?
Because it's a vibration of air particles. So you hear that. That's actually sound. Phoebe. Feelings are not matter. And we all know that feelings don't matter. So, okay. Go ahead, Joshua. Memories are not matter. Very good. Very good. Very good. Achilles. An idea is not matter. Go ahead, Stephen. Time is not matter. Eric just ran out of it because you took his answer. All right. What else is not matter? Joshua. Okay. Why?
Because light is matter.
Okay, what is light then? Anyone can answer this. What is light? Saying the word does not define it. Light is light. Yes. That's very pathetic. What is light?
Energy.
Thank you. Light is energy. Now, name me something about the electromagnetic spectrum or electromagnetic radiation that we talked about last week. Go ahead, Eric. And whom are not good answers.
You're going to have to give me a minute.
I don't have a minute because, after all, time is not matter anyway. Go ahead, Joshua.
Gamma rays are the smallest type of electromagnetic rays.
Okay, smallest what?
The smallest width between the waves.
Okay, you've done a nice job, but let me clean it up a little bit for you. They have the shortest wavelength. Gamma rays are part of the electromagnetic spectrum. They have the shortest wavelength. Good. Give me something else.
Crest is the highest point
Of?
A wave.
Crest is the high point of a wave. Good. Go. Come on. We're on a roll now. Kirby. The trough is the lowest point of a wave. Good. Come on.
The lambda is the distance of a complete wave.
Okay, lambda is the symbol for wavelength, and it is the distance of a complete wave. Very good. Come on now. Eric, your minute's almost up. Let's go. Go ahead, Angel.
Hertz is the unit for frequency.
Hertz is a unit for frequency. Good. What else? Give me some other parts of the electromagnetic spectrum.
The amplitude is 1/2 of the total height of a wave.
Amplitude is 1/2 of the total height of a wave. Give me some other parts of the electromagnetic spectrum. What is the lowest energy part of the electromagnetic spectrum? Radio and TV waves. Radio and TV waves. Okay? Radio and TV waves are the lowest part of the electromagnetic spectrum. What is the second highest frequency in the electromagnetic spectrum?
X-rays.
X-rays. X-rays are the second highest frequency in the electromagnetic spectrum. What is the type, or what is the part of the electromagnetic spectrum that has just a little bit higher energy than visible light? UV or ultraviolet. Very good. UV or ultraviolet. Nope. UV or ultraviolet. Okay?
That's what's going to be everything.
Okay? What is the part of the electromagnetic spectrum that is just a little bit shorter wavelength than visible light? Part of the electromagnetic spectrum that is just a little bit shorter wavelength than visible light? IR, infrared. By the way, how do we remember what the colors of visible light are? Okay, but the rainbow doesn't really help me. You're right, but how do we remember the colors of the rainbow? Roy G. Biv is the phrase we use. Roy G. Biv. Roy, red, orange, yellow. G, green. Biv, blue, indigo, violet. Of those, which one has the highest frequency? What? Violet. Which one has the shortest wavelength? Red. Which one has the lowest energy? It would also be red. Now, not all of those are on your yellow sheet, are they? But there is, I think, blue, green. What else is on there? Orange, yellow, red, violet. Okay? So the element with the highest energy form of visible light is a third period noble gas. Okay? What one is the highest energy form of visible light? Violet. Third period noble gas, argon, ladies and gentlemen. Okay? So again, those are the types of questions, those are the types of things you're going to see on your next test, just so that you are aware of it, and that will be on your final exam day. Questions? All right, excellent, wonderful, ladies and gentlemen. You did pretty good at the start there. When's the last day for getting stuff in, including retakes on the last unit test?
22nd.
The 22nd, which is next week, Thursday, just so that you are aware. This is the slide we were on when we were finishing up last week, Friday. Okay. More wave terminology. I will not ask you for this formula, but there is a relationship between wavelength, frequency, and what is called c, the speed of light. Now, c is an actual true constant, ladies and gentlemen. Okay, a true constant. Kind of like our R values that were constant in the gas laws. C is a true constant. It is a number that is 3.00 times 10 to the 8 meters per second. That is 300 million meters per 1 second. That is how fast light or electromagnetic radiation travels in a vacuum. Okay? Frequency is how often something happens, and in terms of waves, it's how many waves pass a point in a given second. That is determined by the what of the wave? What determines how many waves pass a point in a given second? Not the height, but you are close. Well, that is the frequency that we're talking about. What determines the frequency? The what of a wave? What? The wavelength. The length of a wave. Think about those Volkswagen Beetles going by, one right after another at 65 miles an hour. In the other lane is semi-trailers going by, one right after the other. You will see a lot more Volkswagen Beetles than you will semi-trailers in a minute because they are a much smaller vehicle. So you will see more of them. Same is true with waves. The shorter the wavelengths, the more that will pass a point in a given second because they are all traveling at the same speed. The unit for frequency is hertz. It means waves per second. The unit for wavelength is meters. Now, normally they will take and put nano in front of it. Nano means 10 to the negative 9th. Why? Because when you get into things like gamma and X-rays and ultraviolet, they are very short. When you get into things like radio and TV waves, they are very long. There is a second formula, and again, we don't expect you to remember it, and I will not teach you how to use it. I'm just introducing it to you. That says energy is equal to Planck's constant. That is what H is, times the frequency. Planck's constant is a constant that relates energy and frequency. On your yellow sheet, is Planck on there? Okay, I would probably write down that he has a constant that relates energy and frequency. Planck has a constant that relates energy and frequency to each other. In other words, the amount of energy you get is dependent on your frequency times some number. And it is always the same number. 6.626 times 10 to the negative 34 joules per hertz. So again, this test, ladies and gentlemen, is not only about your knowledge, but it's about your organization. Some of you are in trouble. Because the more things you fill out on that yellow sheet before the test, the better off you will be. But if you are going to, go ahead, sharpen your pencil. It's okay. I don't mind. I can talk over the top of it. Okay? But if you are going to be spending time on a test looking up what the term Hertz is, looking up what Planck is, looking up what all these things are, you are not going to have time to finish your test, because after you figure out what the clue that you're putting down is, which one of those 51 it is, then you got to figure out where it goes. And that, to me, is actually the harder part of the test, figuring out where it goes. Okay? So, questions on any of the wave terminology? That, ladies and gentlemen, is a short introduction to waves. Okay? Now, again, at the end of the hour, some time left, taking a look at worksheet number 1. You should be able to do all that stuff at the top. Okay? Take this out for just a real quick second, ladies and gentlemen, and let's look at this real quick here. Okay? All right. So, quickly, Christopher, how many protons does nitrogen have? Quickly, Christopher, how many protons does nitrogen have? What? 7. What is the atomic number for nitrogen? Angel. See, guys, this is the point where, okay, you came in and you grabbed a calculator. Why? You aren't going to need a calculator in this unit.
Well, I thought it was.
But, again, you're trying to be prepared, which I appreciate. I really do. Now, the next thing to do would be to take out your periodic table when you walk into class. Take out your yellow sheet when you walk into class. And be ready to go, because the more time we spend going through some of these basics, the less time you get to work on things. I'm sorry. We are on a time situation where we need to be done a week from this coming Thursday. Okay, because then the week after that will be, well, 2 weeks from this Thursday. But anyway, okay, that's your final. All right, what's the atomic number for nitrogen, Angel?
14.
No, it is not. Atomic number cannot be a decimal number. Atomic number is the smaller number, which is the same as the number of protons. So, what is the atomic number for nitrogen? 7. 7. Okay? What is the mass number for nitrogen based on the information that is given right here, Jaden? What is the mass number for nitrogen based on the information that is given right here? That would be correct if I were asking you for the average atomic mass. I'm asking you for the mass number. To find the mass number, we take the number of protons plus the number of neutrons, and we add those together, which gives us 15. Thank you very much. Now, what would be the charge of this atom? What would be the charge of this atom up here, Pierce? -3. Really? Based on the information that you are seeing up here, nitrogen would be a -3. Now, I agree with you. Based on where it's at on the periodic table, it is normally a -3. But based on this information up here, what would its charge be? -1. -1. Why is it a -1? Because we take the number of protons minus the number of electrons, and that gives us the charge, ladies and gentlemen. That gives us the charge. All right. So, element that has 13 protons. What is the symbol for that element, Jack? What is the symbol for the element with 13 protons? Al, aluminum. Okay? Now, if aluminum has a +3 charge, Shenza, how many electrons would it have? Nope, that would make it a -3 charge. What? 10. If it has a +3 charge, it has to have 3 more protons than it does electrons. So therefore, its number of electrons would be 10. All right, the easy one, the nice one that should be fairly simple to find here. What would be the atomic number for aluminum, Jasmine? What is the atomic number for aluminum? Look on the periodic table. Aluminum is right there. What is its atomic number? 13. 13. Now, if you haven't noticed it yet, ladies and gentlemen, and sometimes you don't, the atomic number here is always equal to the number of protons here. Always. Never any different. Okay? Now, what would be the mass number for this atom of aluminum, given your information that you are looking at here? Achilles. What would it be? Nope, not 23. For mass number, we are adding protons and neutrons because they are the parts of the atom that have mass. 26. All right, so now, ladies and gentlemen, this last one becomes a little bit trickier because we don't have any of this information here at the start. Well, we do have the atomic number, which can tell us what? What can atomic number tell us? Give me something, Skylar.
Oh, I'm just gonna tell you the answer.
Okay, which is?
Zinc.
Okay, how do you know that it is zinc?
Because of the periodic table, if you look at the atomic number, it's 30, and on the periodic table, the atomic number for 30 is zinc.
Good, perfect, okay. What else does that 30 for the atomic number tell us, ladies and gentlemen? How many, Morgan? There are 30 as well. Very good, okay. Now, we need two things. We need the electrons and we need the neutrons. Well, for electrons, we also need to know what besides the protons? The charge. Why? Because protons and electrons are the part of the atom that have a charge. If you have more protons than electrons, what kind of charge will you have? Positive. If you have more electrons than protons, what kind of charge will you have? Negative. So because this is a +2 or a 2+, it's written either way. Okay? Because it is positive, that means there are more what? Now, how many more is determined not by the charge, but by the number. So since this is a +2, that means there need to be 2 more protons than electrons. We know the protons are 30, so how many electrons would that give us, Morgan? That would give us 28. Now also, to find the number of neutrons, well, we have been adding the protons and the neutrons together to get the mass number, correct? So now we've got the mass number and the number of protons. How do we figure out the number of neutrons? What do we get for the number of neutrons here? 34. Very good. 34. Okay? Very good. Nicely done, ladies and gentlemen. Nicely done. Okay? So, red light has a longer wavelength than blue light. True or false? Okay, what I want you to think about is this. When we did that diagram the other day, when we went from radio and TV waves all the way to gamma, what happened to wavelength as you went across that spectrum? Wavelength did what? Wavelength decreases. So now ask yourself this. Which one is further to the left? Red or blue?
Sorry.
Well,
You're on the
let's,
wrong
and
page.
again, what helps us remember their order? Roy G. Biv. So red would have a what kind of wavelength? Longer, because wavelength is decreasing as you go across. Okay, I know. Hard to visualize, but again, maybe something you want to add to a periodic table or something. As we go across, wavelength decreases. So red light is a longer wavelength than blue light. True or false? True. True. Why? Roy is much longer than the Biv. Wavelength goes longer, becomes shorter as you go across. Blue is further to the right, it is shorter. Green light has a higher frequency than violet. Okay? Roy G. Biv. G in the middle, V at the end. What happens to frequency as we go across that spectrum? It increases. So which one is more, the middle or the end? The end, which is the violet. So this one would be false. Ultraviolet has more energy than infrared. Well, ultraviolet, UV, infrared, IR. Where is IR compared to UV? It is before it. It is further to the left. Ultraviolet is after visible light. So therefore, which one would have more energy? Ultraviolet. Also, we want to avoid ultraviolet. We want to avoid gamma. We want to avoid X-rays. So more energy there. This is true. Microwaves have more energy than gamma rays. False. Microwaves are early in the spectrum. Gamma rays are late. Therefore, that is false. Questions, ladies and gentlemen? Okay. Again, if you want to draw a wave with a crest, draw, and amplitude and things, you are welcome to. I'm not collecting these. 100% up to you, ladies and gentlemen. Questions? All right, ladies and gentlemen, here we go. It's fun time. Fun time because we are going to talk about quantum numbers. Okay, real quick. In an atom of carbon, how many protons does it have? How many protons does an atom of carbon have? 6. So how many electrons does carbon have? God, I was hoping this wasn't going to be the hard question of the day.
6.
Starts out with 6. If you have a certain number of protons, all atoms begin by being electrically neutral, which means your electrons is the same. Protons and electrons are the same. Now, the electrons are arranged according to Bohr models. Bohr gave us the idea of energy levels. He said electrons are in energy levels. How many electrons fit in the first energy level? 2. Well, carbon has how many electrons? 6. 2 in the first, 4 in the second. Every single one of the electrons around carbon has its own set of quantum numbers. All 6. Quantum numbers are kind of like an address. What are the things that make up your address? Give me one thing that makes up your address. The street name.
The city.
The city.
The state.
Will you slow down? Let some other people have a chance. The state. Zip code. House number. Those 5 things make up your address, correct? Okay? You need to describe all 5 if you want to get something delivered to your house, correct? Okay. And everyone's house is unique. There should not be 2 addresses that are exactly the same. Okay? Quantum numbers are kind of the addresses to the electron. And they are based off of 4 things, ladies and gentlemen. 4 things. The first thing, every electron in an atom has a unique set of 4 quantum numbers that describe that electron. 4 quantum numbers that describe that electron. Okay? Well, I know there are 5 things in your address. Let's take out zip code. Let's just take it out. Nobody understands it anyway, except for the post office. What is the most unspecific part of your address?
House number.
Nope. Very specific.
The state.
Less than that even.
State.
The state. First of all, let's figure out what state you're in. Are you in Wisconsin? Are you in Illinois? Are you in Idaho? Are you in North Dakota? Where are you? Let's get a state first, right? Very general. And then we're going to get more specific from there. After state, we're going to look at city. And then after city, we're going to look at street. And then after street, what number on that street, right? Okay. Well, let's do the same thing with the electron. Okay? There are 4 types of quantum numbers, and each quantum number represents something different about the electron. Each quantum number can only have a certain set of values. In other words, we don't just randomly pick things. Every quantum number is a certain number value. And the first quantum number, the most general thing about an electron, is called the principal quantum number. The principal quantum number is the most general thing. And it represents what energy level an electron is in. Okay? Now, how many energy levels are there? No. No. Here's what I will tell you. What is this whole unit on?
Energy.
Nope. What was the title of this unit?
Electromagnetic.
Before that, that was our first topic within the unit.
The periodic table.
The periodic table. So let's let that be our guide. How many energy levels are on the periodic table? What?
7.
7. There are 7 energy levels on the periodic table. What represents an energy level on the periodic table, ladies and gentlemen? What are there 7 of?
Diatomic.
That is true. Diatomics are true, Morgan, but we're talking more general than those. What, Eric?
Rows.
There are 7 rows or 7 periods of the periodic table. Those 7 rows, those 7 periods represent the energy levels that electrons can be in. How many electrons go in the first energy level?
2.
Look at how many elements there are in the first energy level, ladies and gentlemen. How many?
2.
2. How many electrons go in the second energy level? How many electrons go in the second energy level? How many electrons go in the second energy level? 8. How many elements are there in the second energy level? 8. Coincidence? I think not. The periodic table is going to be your guide. Principal quantum number says, okay, what energy level are electrons in? Okay? Now, in reality, it is from 1 to 7. In theory, it can be from 1 to what? 1 to infinity. Because what Bohr taught us and what other scientists have confirmed, if you add energy to an atom, you can force its electrons to jump to a higher energy level, to move around. Which means even if an atom has electrons in the 7th energy level, and you add energy to that particular atom, those electrons could move to the 8th, 9th, 10th, 463,232nd level. So in reality, there are an infinite number of energy levels around the nucleus of an atom. Or in theory, there are. In reality, there's only 7. We're going to keep it simple for you. Okay? In theory, the value could be from 1 to infinity. In reality, it is from 1 to 7 because there are 7 different periods on the periodic table. And please remember, these elements down here at the bottom, these go right here. These go right here. These are part of the 6th energy level. These are part of the 7th. Questions? Good. Okay. So, the letter that they use to represent the principal quantum number is the letter N. And N can have a value from 1 through 7, only whole numbers. So you're talking about 1, 2, 3, 4, 5, 6, and 7. Questions? Okay, good. So now let's get a little bit more specific. Now we're in the state of Wisconsin. Now we need to get into what? The city of Green Bay, wherever, Alouette, whatever. We need to get a little bit more specific. Okay? Which means that within an energy level, there are different areas. Okay? So even though it is one level, it has different areas. Those are called the sub-levels within an energy level. And those represent what are called the types of orbitals. Now, I will show you what the orbitals look like tomorrow because they will blow your mind a little bit, but we will show you what they look like tomorrow. Okay? But every level has a certain number of sub-levels. Okay? Just like every state has a certain number of cities. Very good. They also call this number the subsidiary number. So the first one was the quantum number. The second one is the subsidiary number. Okay? Subsidiary number is the type of sublevel that it is. We used N to represent the principal quantum number. We use L, and this is supposed to be a lowercase l just so that we are all aware, not the number 1, because I know it may look like it. We use a lowercase l to represent it. So what were the values that N could have?
1 through 7.
1 through 7. Well, L has its own set of values that are based on N. And they represent the different sublevels, all having different shapes. So, electrons have what kind of charge?
0.
No, what kind of charge? No, what kind of charge do electrons have? Negative. What do we know about negative charges compared to other negative charges? What will they do when you bring negatives near negatives? No, my God, you guys are talking math. This is science. What will 2 negative charges or what will 2 positive charges do to each other if they are brought near each other? They'll this. Thank you. Can you tell me what this is? They make this funny looking hand and then they do jazz fingers and not attract. They repel each other. Thank you. They repel each other. It's terrible when you can't find the word. But it is right there and you can't find the word. They do repel each other. That is what they do. Which means, can you get a lot of electrons into the same place? Why not? Because they will repel. So these sublevels are ways of keeping electrons kind of away from each other. Okay, you go into your area, I'll go into my area. Okay? So we all have these certain areas that we go to. Okay? Each sublevel is given a different number to represent it because these are quantum numbers. So eventually we got to get to numbers. So your first quantum number, the first part of your address is 1 through 7. What energy level are you in? The second part is what sublevel are you in? Okay? So the different numbers of the sublevels depending on the energy level. The higher the energy level, the more sublevels it has. So in energy level 1, there is a different amount of sublevels than in energy level 7. Well, why? Because as you put a new energy level in, where does it go compared to the last one? Where is the second level compared to the first? What? No, I'm not asking you for a number.
Around it.
What?
Around it.
Around it. So the first level is closest to the nucleus, right? The second level is further away. The third level, further away. The fourth level, further away. Which means every level makes the atom what? Bigger. So if you're bigger, it also means you have more. Well, could, but more, not mass. Because remember, these are just areas. Every time you get bigger, you have more. Starts with an S, ends with a pace.
Space.
Very good, space. So therefore, as you get bigger, you can have more sublevels because you are taking up more space. Okay? Kind of make sense? Good, wonderful, excellent. To find the number of sublevels by integer values. Oh my God, what is an integer value? Like the 2.
1, 3.
Can you give me integer values?
1, 3, 5.
I can't believe you all had Mr. Garai for math that you don't know anything. I find that almost impossible to believe. At least it would explain it, because we all know he doesn't teach anything. Right? See, now I say this, I joke with you, you laugh. One of you is going to go rat me out to him later today, I guarantee you.
It's going to be.
Because one of you ratted me out to Mr. Nast the last time, too, because I saw him right after I talked about gravity and things, and he said, so you're talking about me with gravity again. Okay? When I said you would be attracted to him because he would be the most massive thing around. Okay? So anyway, ladies and gentlemen, integer values, whole numbers. 1, 2, 3, 4, 5, 6, 7. No decimals. Okay?
Or fraction.
And the integer values go from 0 to n minus 1. What was n? Okay, so first energy level, what's the n value?
1.
1! 1 is the first energy level. 1! So what is n? What is 1 minus 1?
0.
0.
Oh.
So how many sublevels are in the first energy level? And don't say 0. 1 represented by what number?
10.
Does anyone understand what the problem with the number n is? Can someone tell me what the problem with the number n is? N is not a number. What is the value of n for the first energy level?
1.
1. So what is 1 minus 1?
0.
So what is the number that represents the first sublevel in the first energy level?
1.
What is it?
0.
What is it?
0.
0!
You just told us not to say 0.
I told you not to tell me that there were 0 sublevels.
Oh.
I didn't say not to tell me that the number representing it was a 0.
Oh.
And this is where it gets confusing. Because the sublevel is represented by the integer 0. Which means there is only one sublevel in the first energy level. How many sublevels are in the second energy level? Take and put a 2 minus 1.
So 1.
1. So what are the integers in the second sublevel? Okay, let's go back. What was the integer in the first sublevel?
0.
0. What are the integers in the second sublevel?
1.
What are the integers in the second sublevel? 0 and 1. From 0 to n minus 1. 0 to 2 minus 1 is 0 and 1. Third energy level, 0, 0, 1, and 2. How many sublevels in the third energy level? 3. 0, 1, and 2. How many in the first level? 1. What number represents it? 0. How many in the second energy level? 2. What are the numbers that represent it? 0 and 1. Third level, how many? 3. What are the numbers that represent it? 0, 1, and 2. Fourth energy level. How many sublevels? 4. What are the numbers that represent it? Good. 1, 2, and 3.
I said 0.
No, you didn't.
Oh, my bad. 0, 1, 2, 3.
0, 1, 2, and 3. 0, 1, 2, and 3. In the fifth level, how many would you have? 5. You want the good news, though? We don't need 5. We haven't found a need for 5. So while you can have 5 sublevels in the fifth energy level, in reality, we only have 4 still. We never go higher than 4. We never go higher than 4. There are up to 7 possible sublevels. However, we currently only use 4 sublevels in any atom that we have on our periodic table. So it's not that we can't have more, we don't need to have more. Okay? The 4 sublevels that we have will fit all the electrons that we need. So the numbers that we use are 0, 1, 2, and 3. Okay? 0, 1, 2, and 3. So in the first energy level, you would have 1 sublevel. So your quantum numbers would begin 1, comma, 0, comma, something. 1 representing the first energy level, the principal quantum number. The 0 representing the subsidiary number, the sublevel that the electrons are in. Questions? Good. Wonderful. Excellent. Awesome. Let's see what next. Oh, by the way, we didn't think this was good enough. So they decided to give each sublevel a letter as well. Each sublevel got a letter as well. So here are the letters, ladies and gentlemen. The 0 sublevel is represented by the letter S. The 1 sublevel is represented by the letter P. The 2 sublevel is represented by the letter D. And the 3 sublevel is represented by the letter F. Why? Because we wanted a shorter way than writing out 4 numbers for a configuration. So we shorten it up by using these letters. Okay? We'll show you what we mean in a minute. Questions? Good. Everybody's head is still attached. So, ladies and gentlemen, here are the quantum numbers from 1 to 7. Here are the possible sublevels for each of those. However, we never go higher than what?
5.
We never go higher than 4. So even though there could be this number 4 here, doesn't happen. Even though there can be 4 and 5 here, doesn't happen. Even though there can be 4, 5, and 6 here, doesn't happen. Okay? Could. Possibly. Someday, big enough atom might need it. Don't right now. Questions? No? 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 Wonderful. Wonderful, wonderful. Okay. Our third quantum number, ladies and gentlemen. You're going to like this one. Represents to the, or is the number of orbitals related to the sublevel. So the sublevels depend on the energy level. The third quantum number depends on the sublevels. Okay? And it is called the azimuthal number. Does anybody know what azimuthal means? Anybody ever hear of the term azimuth? azimuth represents orientation in space. Which way is this ruler going? Vertically, up and down, correct?
Left and right.
Are those the same? Are they the same orientation? No. This is going up and down. This is going horizontal. How about this? So is it the same as this?
No.
Why not?
Because it's direction.
Because this is going which way compared to you?
Left to right.
How about this?
North and south, or forward.
Forward and back.
At and away from you, correct? Can we agree that this is different than this, which is different than this? So how many orientations have I just shown you? 3 orientations. So you can have different orientations in space, okay? Now, here's the nice part about it. If you put electrons in this orientation, guess what if you put some in this orientation? They don't come very close to each other. Because some are in this orientation, some are in this orientation, and then guess what? Some are in this orientation. Why? So they can stay away from each other. Why? Because they repel each other. They repel each other. Okay? So, this azimuthal number represents the orientation of an orbit. How that suborbit, how that sublevel is orientated in space. Okay? How that sublevel is orientated in space. Okay? Now, the letter M represents it. So we had N representing the quantum number. We had L representing the sublevels. And now we have M representing the orientations of these sublevels. Okay? Questions? Good. I'm glad you're staying with me. The different orientations of the sublevels in space around the nucleus. And they run in value from negative L to L. What was L? L was the sublevel. Okay? So in the first energy level, what number represents the sublevel? 0. So what are the values from negative L to L if L is 0? 0. So how many values is that?
1.
It's 1. That's 1. Can you name me a shape that no matter how you move it, how you orientate it, it looks exactly the same? Try again. 3-dimensional, not 2.
A sphere.
Sphere. A sphere, ladies and gentlemen, looks exactly the same no matter how you look at it. How many possible orientations can you have of a sphere?
Infinity.
Really?
Oh, 1.
1! There's only one way to orientate this because no matter how you look at it, top, bottom, left, right, up, down, it don't matter. It all looks the same. How many different ways could I orientate this? 1, 2, 3, right? So depending on the shape of your sublevel determines how many what? Orientations it has. The S has a shape of a sphere. There is only one way to orientate that in space. Okay? But what about if we put the second energy level? The second energy level, what are the sublevel? What are the numbers of the sublevels? 0, 1. Well, guess what? When you get to 0 again, what's the shape? Sphere. Only one way to orientate this, right? But now, if we use the number 1 in there, what values do we get from negative L to L? Count all the integers. What are they? Negative 1, what? So how many orientations are there for the sublevel? There are 3. So in the first energy level, there's only one sublevel. In the second energy level, there are 2 different sublevels. One that has only one orientation and one that has 3. One that has 3. Okay? One that has 3. So, that's 3 of the 4 quantum numbers for electrons in the first energy level. 1 representing the first energy level. 0 representing the S sublevel. 0 representing how many orientations it can have. Only 1. Right? This means 1 sublevel. This means 1 orientation. We only have 1 number left. However, in the second level, now you've got 1, which can be 0 and 0, but you also have 2. Okay? 2. So now, what values can you have for the second number? 0, and you can have 2, 1. Right? If this is a 0, what is the third value here? What is the M for the 0? 0. Always. Can't be anything different. Well, what could it be if it's a 1? Could be what? 0, -1. Keep going. From negative L to L. Here's L. So what are the values that it could be? -1. 0. 1. 3 different orientations of the same sublevel. Only 1 orientation of this sublevel. Questions? Principal quantum number. Sublevels. Orientations. For the S, there is always only 1, the 0. P represents what number?
1.
1. So you can have -1, 0, and 1. -1, 0, -1, and 1. -1, 0, 1. Right? What if you got to a higher level and there was the 2 value for your sublevels? Well, now, what are the orientations for a 2? -2, -1, 0, 1, and 2. So as we go down energy levels, what happens to the amount of space? It increases. Every level can hold more electrons. And if you get all the way to an F, which has 4 sublevels, in the F, you can go -3, -2, -1, 0, 1, 2, and 3. So these, 1, 3, how many of these?
2.
How many of these values are there? 1 value here, 0. 3 values here, -1, 0, and 1. How many values here? 5. How many values here? 7. Keep that in the back of your mind. Keep that in the back of your mind. Only 1 quantum number left, ladies and gentlemen. That's the good news. 1 quantum number left. That 1 quantum number that's left, ladies and gentlemen, is called the magnetic spin. The magnetic spin, ladies and gentlemen, is just that. If this ball were spinning Spinning, 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 spinning. What are the two directions it can spin? Okay, well, if it's up and down like this, what direction is this spinning right now? At you. Okay, I'm not going to change this, right? Not going to change this. What direction is that spinning right now to you?
Left.
Left. Like a what? Like a clock?
Counterclockwise.
This is now spinning counterclockwise, correct? Okay, what if I do it kind of like this on an angle? Guess what? Hasn't changed the direction it's spinning, has it? Okay, so what are the two directions that this can spin? That's it. Counterclockwise and clockwise. Now you're right, it may not be facing you, but it's still spinning either counterclockwise or clockwise. Right? That's it. Those are the only two directions things can spin. Now, we represent that, ladies and gentlemen, with a value of plus 1/2, minus 1/2, or we could use simply an up and a down arrow. And I don't care which arrow you're talking about. If you say the plus 1/2 represents clockwise and the minus 1/2 represents, it doesn't matter. One represents one represents the other, correct? Here, this one represents counterclockwise, this one represents then. This one was counter, this one would be clockwise. They got to be different. That's all they got to be. That's all they got to be, is different, correct? So, that means that at most, there are only 2 electrons allowed per orientation. 2 electrons allowed per orientation. That is it. 2 electrons allowed per orientation, ladies and gentlemen. Because if you put a third one in there, what would it have to be doing? What direction would it be spinning compared to one of the other ones? How many directions are there for something to spin? 2. So if you put 3 electrons into an orientation, what does that mean? 2 of them have to have the same spin. Be like 2 houses on the same block having the same address number. Which one do they deliver the mail to? We don't know. Every house has to have a unique number, right? So, we figured out what state you're in. What energy level are you in? We figured out what city you're in, what sub-level. We figured out what orientation you have. What is the street name? And now, ladies and gentlemen, we figured out what the address is. Are you spinning clockwise or are you spinning counterclockwise? You can describe every electron around the nucleus of an atom in those 4 numbers. In those 4 numbers. Okay? So electrons pair up in an orientation. 2 of them in one orientation, but they spin in opposite directions. They spin in opposite directions. Therefore, the total number of electrons depends on the number of orientations. The number of them. How many orientations are there? How many orientations were there for a 0? 1. So how many electrons fit in the 0? Electrons pair up in an orientation. How many electrons fit in the 0 orientation of a 0 sublevel? We'll read it again. Electrons pair up in an orientation. 2. Now, how many orientations are there if your energy sublevel is represented by the number 1? Negative L, 2L. 3. Which means how many electrons in each one of those? 2 for a total of 6. Okay? A D goes from -2, -1, 0, 1, 2. How many sublevels? 5. Sorry, orientations, not sublevels. 5 orientations. How many electrons total? 10. 10. And then if we get to an F, -3, -2, -1, 0, 1, 2, and 3, how many is that? That's 7, which means how many electrons total? Really? 21. 7 different orientations. 2 electrons in an orientation, and that's 21.
14.
Very good. Much better. Much better, much better, much better, much better. All right, ladies and gentlemen. So, here it is, laid out for you. Principal quantum number 1, sublevel 0. 0 is the orientations, which means there's 1, which means how many electrons can fit in there? Well, if there's 1 orientation, 2 electrons total, correct? How many orientations are there between the S and P's here? How many orientations are there between the S and P's here? How many orientations between the S and the P's here?
4.
4. So how many electrons?
8.
1 here. This 0 is different than this one. 1 here, 3 here. 4 orientations, 8 electrons total. How many orientations here? 9. 1 here, 3 here, 5 here. 1, 3, 5 gives us 9. How many electrons total? 18. How many here? 16. 1 and 3 is 4. 4 and 5 is 9. 9 and 7 is 16. Total of 32 electrons. That means that the first energy level can only hold 2. The second energy level can only hold 8. The third level can hold 18. The fourth level can hold 32. And guess what? We never need a level to hold any more than that. There they all are. There they all are. Questions? Now, here's where it gets cool, ladies and gentlemen. How many electrons in the first energy level did we just say it can hold with its 1 orientation?
2.
How many elements are in the first energy level?
2.
2. There they are, ladies and gentlemen. How many electrons can the second energy level hold? 8. 2 in the S sublevel, 6 in the P sublevel. Total of 8, correct? 1, 2, 3, 4, 5, 6, 7, 8. There they are, shown out for you. How many can go in the third level? How many? 18. Huh. How many are here?
18. Or no.
Oh, 8.
8. Wait a minute, we're missing how many?
10.
10.
On the top.
We're missing 10.
Can you go update?
The first
We're
two
missing 10.
levels. First two levels.
We're missing how many? Weird, because there's... How many right there? 10. 10. That's that other energy level. That sublevel. What's the last number?
32.
32, right? Okay. Well, here's 2, right? 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Still missing 14. Where the heck did those other 14 go? What?
The ones down below. 67.
Huh. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14.
115,
That's a great theory, Phoebe.
I guess.
Well, good guess, because you're still right.
Oh, okay.
Because what are you forgetting about these 15? Where did they go?
In the 67.
Well, wait a minute. There were 18 here, right?
Yeah.
Because there was one here. Where's this one?
That's on the bottom.
There it is. So in reality, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 15.
32.
There's your 32. There's your 32, ladies and gentlemen. There is your 32 elements, all laid out on one nice sheet of paper that you could use on any test. All laid out there for you. Matter of fact, if we want to look more closely at it, ladies and gentlemen, look at this, look at this, look at this. These in here, ladies and gentlemen, these are the 10 Ds that we were talking about. The 5D orientations that hold 2 electrons apiece. There are the Ds. Well, wait a minute. Let's go back. What was the first letter for the O or 0 sublevel? S. How many electrons can it hold? 2. Well, there they are in the first level, right? But then look at it. There they are in every other one. These are the S's. These are the 2 S's. Why? Because we're in the second period. Okay? Now, after these S's fill up, what then do we start filling? The P's. How many P's are there total? 3 orientations, right? How many electrons all total? 1, 2, 3, 4, 5. Oh my gosh. Look at there. There's all your P's, ladies and gentlemen. These are 2 P's. These are 3 P's. These are 4 P's. These are 5 P's. All laid out right there for you. Then these are your D's. And these down here are your what? Those down here are your F's. Now, here's the weird thing, ladies and gentlemen. This is it. Last thing for today, I promise you. This is 1S, correct? This is 2S, correct? This is 2 what? 2 P's. This is what?
3s.
This is 3 P's. This is? What are these? Which D's?
4.
No, they're not 4. When do the D's start? What energy level? Nope. Nope, not up here. No room.
Water.
They start in the what?
1.
No,
What?
not in the first. Now, I want, maybe you're giving me a different number than I'm thinking you are. Is there room in the first for 3 energy levels? Is there room in the second for 3 energy levels? When is there finally room for 3 energy levels? The third. So if these are the 3 S's and these are the 3 P's, what are these? Those are the 3 D's. But guess what? They're one behind. When do you have room for F's? In what energy level? Not in the first. Not in the second. Not in the third. Fourth. Guess what these are down here? Those are your 4 F's. These are your 5 F's. They're a little bit behind. We'll explain why tomorrow. Go ahead, Joshua.
So
Helium is a 1s. Helium is actually 1s2 because it has 2 electrons in that s. Okay? Very good. Very good, ladies and gentlemen. Very good.